Hi everyone. Now, I'm going to talk about one of the use case that we recently developed on Clara, which is infrastructure as a code metrics. With growing adoption of cloud, teams need to use automation to create resources in the cloud. The tools could be Terraform, CloudFormation, or any other depending on the cloud provider. Since there are multiple teams who are using these resources and creating those resources, there is a need to apply governance to know how our infrastructure pipelines are getting executed, what resources are getting created, and how can we further optimize these pipelines. Keeping these problem statements in mind, we have come up with this use case that connects to Terraform, Ansible, and Jenkins to pull the essential metrics related to the execution, like how much time the pipeline took to execute, what are the common errors, where the time is getting spent, what are the cloud resources that are getting created, that would help the operations team and the project teams to know the overall visibility into the underlying cloud environments. With this end-to-end monitoring, the teams can identify any anomalies as well, where certain pipelines are failing repeatedly or certain resources are getting updated frequently. That would allow teams to look at the root cause analysis and take some corrective actions. All notifications can be published to Slack channels for easy action by different teams. Typically, in an enterprise, the Terraform scripts can be executed using Terraform Cloud, from where we can pull these metrics, and Ansible from the Ansible Tower. Some of the benefits of the use case involves identifying the long running jobs and how can we identify. For example, if my pipeline is taking too long, is there a need to break it down into multiple sub pipelines so that my resources can be created easily? If there are any errors, we can identify whether the error is due to my infrastructure issues or the permission issues. The analysis of these pipelines also helps us to track the changes which are deployed across environments. So what are the frequent changes? Are we updating our security groups quite often? Or are we creating new instances in the lower environment? That helps us to optimize the end-to-end pipelines for both infrastructure provisioning as well as software configuration. Now, let me take you to a brief demo where we have set up some sample pipelines in our test environment. This is one of the sample scenarios that we have come up. So we are using the Azure DevOps for storing all our Terraform and Ansible scripts, but this could be any other source code repository as well. So there are a couple of repositories. We have one for Terraform and one for Ansible, which host the scripts. So in this scenario, we are creating a couple of resources in AWS and then installing a sample application using Ansible on top of that. With the commit repository, we are able to see that, okay, how many files, how many repositories are there, the total commits across each of these repositories, what are the files, and where files are getting added and deleted. So for example, we know that this Ansible file is the most committed one, and then we have a Terraform file as well. So this is how you can have an analysis and visibility into overall infrastructure and configuration scripts in your code repo. In the current use case, we have integrated this Azure repo with Ansible Tower and Terraform Cloud, wherein any commit that happens triggers the corresponding pipelines through these tools. So let me walk you through the infrastructure pipeline. So this is the summary from a Terraform perspective. So right, we start with an organization. So there is a single organization and workspace that we are operating. And what are the number of resources that are getting created? So you can see that One is an AWS instance and another one is the security group. How many runs we have executed so far and how many of them have failed. In case of failures, what are the different errors? So we can say that there are errors related to creating a security group. There is an error related to instance where a certain configuration was incorrect. So that way, each of these error results into some modification in our script. We can also see that, okay, what's the time taken to execute our script? So the plan phase took around 8.5 seconds, while the apply phase is 6.3 seconds. We know that, right? What are the different stages, right? So there are 5 errors. There are, out of the 5 successful runs, 3 were applied and 3 were just planned and finished. That means there were no changes to be applied into the underlying infrastructure. Now, getting all these details directly from the Terraform cloud is difficult. It takes multiple APIs and creating a suite that can extract that information and provide this visibility. This dashboard provides direct visibility to different teams to track what's going on. Also, we can further drill down into each of the run details to see that, okay, what was the execution timeline for that? For example, the specific run, the end status was applied, it got created at a certain time, and then how much time it took, right, to eventually get applied. Similarly, we can drill down into the plan details and apply details as well. One of the important things that you can see is that for each plan, we can see that, okay, the number of resources that are getting added or deleted or changed. This helps us to keep and track of what all resources are getting created, right, by different scripts and teams. Now, once we have our infrastructure ready, the next step is to run and deploy applications on top of that. That's where the software configuration tools like Ansible comes into the picture. Again, details that we can show, right, are how many jobs are getting executed, what is the average execution time, what are the failed jobs. You can see that there are certain errors which are related to the infrastructure where certain free space is not available, certain system errors are there. So that helps us to debug that what's going wrong. We can know that, okay, for each job, what was the highest time that it took. We can categorize the jobs by projects status, that there are 8 failures out of 15. And then what are the different inventories that we have, right? And then, okay, which inventories are being used by different kinds of jobs. Again, a lot of this information is not directly available from Ansible Tower, but have certain APIs have to be used to extract that information. These use cases can be further extended to provide relevant details like the specific details of the inventory against which host these scripts are running. And that's where Clara can be extended further to create a specific custom use case depending on the needs. That's all we have in this demo. Thanks a lot for listening to this.